Okay guys, welcome to this year 10 foundation tier manipulating expressions, and it's from the White Rose Maths scheme of work. So White Rose Maths are a fantastic scheme of work for all levels ranging from preschool maths, I believe actually, or like early years maths, okay, right the way through and including post 16 level maths, because so it ranges with GCSE maths, key stage 3 maths, and it's also split into subsections for year 7, year 8, year 9, year 10, and year 11. Like level maths, okay, for that, okay, and also year 6 maths, year 5 maths, year 4 maths, year 3 maths, year 2, and so on and so forth, okay, in year 1. Okay, we're going to start with question number 1. We're simplifying this expression, t plus m plus 3t minus 2m. We're collecting my like terms, t plus 3t, so I've got 1t there, 1t plus 3t is equal to 4t, and then I've got m subtract 2m. I've got 1m subtract 2m, which is equal to minus m. Okay, so my final answer is 4t subtract m, or minus m plus 4t. Okay, either way would suffice. Okay, as long as the signs are consistent. Okay, should be an m there. Okay, sorry about that. Okay, so that's the first one. Okay, so it's collecting like terms there. Okay, so you collect all your t's together and all your m's together. Question number 2, solve 2/3 d is equal to 12. Well, if I divide both sides of the equation by 2/3 to isolate and get d by itself. Now, dividing by 2/3 in mathematics is the same as multiplying by its reciprocal. So dividing by 2/3 is the same as multiplying by 3/2. Okay, dividing by 2/3, okay, same as multiplying by 2/2. Okay, 12 divided by 2/3. A number divided by a fraction is called the KS4 method. You keep the first number and or fraction the same. You flip the second fraction. Okay, so it goes to 3/2. Okay, you invert it and then you change the division to a times. Okay, 12 lots of 3/2. Well, 12 times 3 is going to be 36. So it's going to be 36 halves, which simplifies to 18. So d is equal to 18, guys. Okay, and you can work it out. Okay, if I do 2/3 multiplied by 18, okay, if I do 2/3 of 18, a fraction of an amount, okay, or a fraction times the whole number. Okay, 2/3 of 18 means I do 18 divided by 3, which is 6, and then times by 2, which is going to be 12. So that is right. Okay, question number 3, represent the solution to the inequality y halves, okay, y over 2 is strictly greater than 3 on the number line. Well, if I multiply both sides by 2 to isolate and get y by itself, I get y is greater than 3 lots of 2, which is going to be 6, so y is greater than 6. Okay, so it's going to be like a hollow circle. Y is greater than 6, so y is bigger than 6. So y can take values 7, 8, 9, 10, 11, so on and so forth, and even values of 6.01, 6.1, 6.2, 6.3, so on and so forth, okay, as long as the number is bigger than 6, okay. Question number 4, show that this expression is equivalent to 4a plus 4. So 14 lots of a plus 1, subtract 10 lots of a plus 1 is equivalent to, i.e. the same as 4a plus 4. Well, expanding the left-hand side actually of my, we will call it, like a equality here, because they're actually same actually on both sides. So expanding it, so 14 times a is going to be 14a. 14 times 1 is going to be positive 14. Negative 10 times a is going to be minus 10a. And then negative 10 times positive 1 is going to be minus 10. Okay, so collecting like terms, 14a subtract 10a is going to be 4a, and then positive 14 subtract 10 is going to be positive 4. Okay, hence we get the expression on the right hand side. Okay, so this is what I'll call like the equivalency sign. Okay, so a So the left-hand side is true for all values of a, as is the right-hand side, actually, if that makes sense. Yes. So yeah, they're both actually essentially the same as another. Okay, they're what we call equivalent expressions. Okay, equivalent sums. Question number 5. Circle the expressions that simplify to 6a cubed. Okay, so taking our time here. So this one, 24 divided by 4 is going to be 6. And then I'm going to have a cubed, and then b divided by b is equal to 1. Okay, so this one does simplify to 6a cubed. Okay, yeah, so this one does, yes. What about this one? Well, that would actually give us 6a cubed. Yep, so that is also correct. Okay. What about this one? Well, 3 times 2 is 6. A squared times a is equal to a cubed. Here, we would obviously add the powers. Okay, think of it as the invisible 1 there. So it'd be 6a cubed. Okay, this one, it wouldn't, because I cannot combine a's and a squareds together. Okay, if I was multiplying 6a with a squared, then absolutely yes. But because I'm adding it, okay, that does not simplify. I can factorize that, but I cannot combine that any further, okay, because a and a squared are not like terms. Okay, so hopefully that makes sense. Question number 5. Mo says 5n plus 5 is a multiple of 10 for all positive integers of n. Use a counterexample to show that Mo is incorrect. Okay, so if I factorize this, so 5 lots of n plus 1. Okay, so this is always going to be a multiple of 5, but not necessarily 10. Okay, so integers means whole numbers. So let's obviously try. Okay, so when n equals 1, I'm going to get 2 times 5, which is going to be 10. When n equals 2, here we go. Okay, so n equals 2, then I'm going to get 5 lots of, okay, 2 plus 1. 2 plus 1 is equal to 3. 5 lots of 3 is going to equal to 15. And 15 is not a multiple of 10. Okay, multiple of 10 means the 10 times table. Okay, or 10 times tables. Okay, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, so on and so forth. Okay, 15 obviously, yeah, is not divisible by 10. Okay, it goes into it, but it has a remainders here, but it doesn't go into it fully, if that makes sense. This next question, question number 7. So k is an odd integer, so the expressions which are always odd. Well, odd integer is in the form 2n plus 1, okay, or 2n minus 1. Oh, I've put like an h there, sorry. Okay, so for something to be odd, okay, so if I add 2 to it, then that'll be 2n plus 3, so that will be odd. This, it wouldn't, because if I subtract 1, then I would actually get, yeah, just 2n, so it can't be that one. So 2 lots of this, well, that will give me 4k plus 2, so no, that wouldn't work, actually, because that would, yeah, because an odd times even will always be even. And this one, well, if I square an odd number, I will always get an odd number. For example, 1 squared is 1, 3 squared is 9, 5 squared is 25, 7 squared is 49, 9 squared is 81, and then obviously 11 squared actually is 121, so it ends in a 1. Okay, 13 squared is 169 actually, so on and so forth. 15 squared actually is 225 actually, and then so on and so forth. Okay, for that one. Okay. T is an even integer. Circle the expressions that are always even. Well, this one definitely is. Okay, yeah, because it's two lots of an even number. Okay, this one also is, because odd times even is always even. Okay, so being very actually careful here. So even is in the form just 2n, okay, or 2k or 2p or 2h, whatever letter you want to use. Okay, if I add 5, that will actually make it odd, so that's not going to make it even, so that one's going to be a cross. Okay, and then this one, well, an odd plus even number, well, let's look at it. 3 plus 4 is 7, 1 plus 2 is 3, so they always give you, okay, odd number answers, so that one is also incorrect. Question number 8, 25m subtract 2n subtract 4m plus 5n is equivalent, okay, i.e. yeah, the same as something, so pm plus qn, find the values of p and q. So collecting like terms again, guys, collecting all my m's together and all my n's together. 25m subtract 4m is going to be 21n, and negative 2n plus 5n goes to positive 3n. Okay, minus 2 plus 5 is equal to positive 3. Okay, negative 2 and you add 5 and I get to positive 3. So P is equal to 21, okay, and Q is equal to 3. Okay, so they are your coefficients of M and N respectively. Okay, so this is what I call the equivalency sign. Okay, so it just means that they're equivalent. Question number 9. Amir thinks of a number 4 more than 2/3 of a number. Actually, so we'll label that. So 4 more than 2/3 of a number. So we'll call his number just capital X just to make it clear. So capital X, okay, is equal to 18. Form and solve an equation to find Amir's number. Okay, so yeah, the first part's done actually, so we have actually formed it. So I'm going to subtract 4 on both sides to balance the equation respectively. So I have 2/3 X, okay, is equal to 14. Okay, I'm now going to divide both sides by 2/3. Okay, remember guys, dividing by a fraction, you are multiplying by its reciprocal. So dividing by 2/3 in maths is the same as multiplying by 3/2. Okay, you multiply by the reciprocal. So you flip the fraction upside down. Okay, so dividing by 2/3 is the same as multiplying by 3/2 or 3/2. Okay, 14 times 3 is going to be 42. 42 divided by 2 is going to be 21. So Emil was thinking of the number 21. Okay, and I can double check that. Okay, 2/3 of 21, well, that will equal to 14, okay, because 2/3 of 21, a fraction of an amount, I do 21 divided by 3, which is going to be 7, times 2 is going to be 14, and then 4 plus 14 equals 18, so that does prove my answer is correct, okay. So just obviously be clear, guys, yeah, dividing by a fraction is the KFC method. You keep the first fraction and or number the same, you flip the second fraction, so yeah, you find the reciprocal of the second fraction, so you turn it upside down, and then you change the division to a multiplication, guys. Okay, yeah, so in this context, dividing by 2/3 is the same as multiplying by 3/2. Okay, yeah, dividing by 0.6 reoccurring is the same as multiplying by 1.5. Okay, and if you're not sure, guys, yeah, obviously check on your calculator, yeah, but yeah, dividing by a fraction, okay, yeah, you multiply by the reciprocal. Okay. Right guys, that's the end of today's video. Hopefully you found it useful. Okay, if you did, please like, please comment, please share, please subscribe, and follow me on my TikTok page, and I'll see you all inside the next video. Okay, bye for now. Take care. All the best with your end of year tests and end of year exams. Okay, for those of you in year 7, year 8, year 9, and year 10, and even in year 5 as well, guys, yeah, or year 4. Okay, good luck with the revision, and I'll see you soon. Okay, bye for now. Take care. All the best.